In this video, we're going to talk about the standard normal distribution. So in the previous video, we learned about what the normal distribution was. It was centered around the mean. You had the 68, 95, 99.7% empirical rule for the different, distances you go from the mean. However, the standard normal distribution, the only thing that makes it standard is that your mean is going to be 0 and your standard deviation is going to be 1. So that simplifies our graph here. Instead of the center having to be, some weird number mu, the center is just 0. And then if you go left and right 1, that's where you're going to get 68%. If you go left and right 2, that's where you're going to get your 95%. And if you go left and right 3, that's where you're going to get your 99.7. So the only thing different about the standard normal distribution compared to just any old normal distribution is we are focusing and saying that the mean is going to be 0 and the standard deviation is going to be 1 for these. Now, why do we care about this? Why are we making a big deal out of this? And this goes back to what I said in the previous video when we were trying to find areas. If I have a normal distribution and the center is at 50, and I want to find the area that is everything to the right of 60, that would be the probability x is greater than 60. However, if I had a different normal distribution, where now my center is, say, at 40 here, and I want to find the probability that x is bigger than 60, we're generally going to have a different area there. So it's not like I can look up on a table and say, I want the area bigger than 60, and I get the number, and then that's it, you're done. Because you would need to have a table for every different mean. In fact, you have to have a table for every different mean and every different standard deviation, and that'd be a nightmare. So what they realized is they can take any distribution, we're going to convert it to the standard normal distribution, and at that point, all you need is one table for the standard normal distribution, and then on one of them it might say, let's find the area to the right of 1 now, and then the other problem, maybe we're trying to find the area to the right of 3. So maybe this small area is the purple one, and this area is the red one. And so instead of trying to look up 60 on our table, we're going to either look up, say, 1 or 3 on our table. And that way we can get the area for any normal distribution by converting it to the standard and then looking up the standard table and getting our answer from there. Now, as I also said in the last video, we don't really need to use a table anymore because our graphing calculators can handle doing this for us. And at that point, you don't even really need the standard normal distribution for that type of problem anymore. You can just use the regular normal distribution with whatever mean and standard deviation you have, plug it in your calculator, and it spits out the answer. We're still going to cover this because it's still talked about, it's still something you should know, and maybe you will want to use a table. You're free to do that, but it's just not as efficient anymore. So the question is, how do we convert into the standard normal distribution? So here's the idea is we're going to have a variable x that we're talking about, and x is normal distribution, and it's going to have a mean of mu and a standard deviation of sigma. Then if you want to standardize it, what you're going to do is you are going to calculate the following, the z value, x minus mu over sigma. Now this is actually not a new formula. We talked about z-scores in a much earlier video, and that's really all we're doing here, is finding the z-score. And once you do that, guess what? Now you have a standard normal distribution. Now with that said, let's do an example here where we're going to find the area for a standard normal distribution. And we will use our calculators for this. So I will show you a calculator video separately where we get the answer. But for right now, let's just see what we can get here. Let's find the probability that x is greater than 60 if your mean is 50 and your sigma is 10. So this is actually this exact problem right here. So what we would do is we would calculate our z-score. We would take the x value of 60 minus the mean of 50 divided by the standard deviation of 10. That gives me a z-score of 1. And so that means that the probability that x is bigger than 60 is the same as the probability of z is bigger than 1, because x being 60 corresponds to z being 1 based on this formula we just used. And now for this one, we can go ahead and use the empirical rule, but you could also use your calculator, which again, that'll be a separate video. So if I want to use the empirical rule, so this is going to be 0 and 1. We're trying to find this area to the right of 1. Well, what do I know? I know that if you go between -1 and +1, that total area is 68%. That means that this half of that area on the right is going to be 34%. I also know that if you start at 0 and go all the way over, that area is 50%. And so that means this part here that I'm looking for, it's going to be the green part minus the purple part, is 0.50 minus 0.34, or there's a 16% chance of this happening. Now that was a bit tricky, I will totally admit, but as I said, I will have a separate video where we do this in a calculator and it will just go straight through much easier. Now I like showing different ways because different students like different methods. Some will like using the calculator, some will hate it and would rather do it by looking at like geometry like this. And it doesn't really matter to me which way you do it, whichever one makes more sense to you. So I will show you the different ways and you choose which one you prefer.